Hello, students, and welcome back to science class. Today, we are going to be doing a couple of different things, starting with our scientist of the week. After I share with you who the scientist of the week is, our next item on the agenda is to complete some lesson notes, and those lesson notes will be completed on page 22 of your book. After we finish just a few of our lesson notes, and we'll save the rest for tomorrow, but after our lesson notes, you will then use the rest of your time to work on the classroom activity on page 21. And of course, as usual, all of this will be outlined in our one-stop shopping Google Classroom. So let's get started here with our scientist of the week. Our scientist of the week this week should be an easy one to remember because it is none other than myself. Henry M. Skirst, born October 18th, 1968, is our scientist of the week this week. And my claim to fame is that I've created this science program that you are enjoying right now. So if you can remember the name and proper spelling of the scientist of the week and his claim to fame, you too can earn some bonus points on this week's quiz. So I hope you can remember my name. All right, now let's get started with some lesson notes here. So if you turn the page in your book, page 22, you can follow along in your book as I explain some of our notes as you are writing them down in your book. Pay particular attention to the red words as we go through our notes because those will be most important for you to record in your book for your notes. And remember, the quiz is an open book quiz. So the more you write down in your book, the more help you will have on the end of the week's quiz. So let's begin. Let's start with one of my favorite characters who is in the laboratory, Kermit the Frog here. And when you think of a frog in general, and you think of science class, does anything come to mind? Oh, some of you might be thinking frog dissection. And in fact, that is what many people think. And imagine, to the dismay of Kermit, opening him up and examining his insides, for that is what dissection is all about. Opening something up and examining what makes it tick, what makes it what it is, and checking out the insides. Well, we're going to do a little dissection today. But no, don't worry, Kermit. We're not going to be using the frog to dissect, but rather we're going to dissect words. You see, in science class, it is extremely important for you to be able to dissect words, to know what words are made out of, so that you can figure out how they tick. Because in the course of your study of science, you're going to encounter many, many different words. And if you know how to dissect these words, your understanding of science will be greatly improved. So let's begin with the basics. I'm sure you've heard in language arts class these terms here, prefixes and suffixes. Do any of you know where a prefix comes? Where does a prefix come? Does it come at the beginning of a word or at the end of a word? Where do prefixes fall? If you said they come before a root word, you are absolutely correct. In fact, if you look at the word prefix, can you figure out what the prefix is of the word prefix? Say it out loud if you think you know. Did you say pre? You're absolutely correct. Prefix is the prefix of prefix. So prefixes come at the beginning of a word. So if prefixes are at the beginning, where do you think suffixes come? Very good. At the end of a word, or they come after the root word. Now notice, do you see how, let's see, there we go. Do you see how these sections here are bolded and red? That is a clue for you to be writing those down in your book. So if you haven't started writing these down in your book yet, make sure you're writing these down on page 22, your notes page for this particular topic. All right, let's continue. So prefixes come before a root word, suffixes come after a root word. So in science, let's think of an example. Let's take the prefix micro and the suffix meter. We can take these different parts of words and actually put them together. And if we put micro and meter together, we actually form a new word, micrometer or micrometer. Now, you've done your vocabulary already this week, so I want you to be thinking about, that prefix micro. What does micro mean? And what does meter mean? If you know the meanings of certain key prefixes and suffixes, then when you see new words, you may be able to define them yourselves. So micro, call it out if you know what the prefix micro means. Very good. Small. How about meter? What does the suffix meter mean? If you're not sure, take a quick moment to turn to your glossary in the back of your book, because I'm going to ask you in a moment what you think the word micrometer means. And remember, it's both of those together. All right, did you get the meaning of meter? What is it? Measurement. Very good. So if you put micro and meter together, literally you get the word small measurement. Well, I have an object here which happens to be a micrometer. This is a micrometer. See it? It's like a type of ruler. And this micrometer is used to measure things that are really, really small. So let me show this to you in action. I am going to donate a piece of myself to science. Here we go. I'm going to take a beard hair out of my face with tweezers. Ow! Oh, ow. Ooh, that was a good one. And I am going to place it into the micrometer to get a measurement here. Now, you wouldn't measure a beard hair using a typical ruler or a meter stick because beard hairs are way too small. But here we have this micrometer, and I'm going to show you the reading In millimeters, it is 0.12 millimeters. So this beard hair that I just took out of my face measures 0.12 millimeters. That's about 1/10 of a millimeter. And a millimeter is pretty small. It's about the thickness of, it's about the thickness of your fingernail. So take your fingernail and chop it into 10 different sections, and that's about the thickness of my beard hair. All right, so hopefully you get the idea. In science, you're going to encounter many different words. If you look at the different parts of these words, if you know the meanings of certain prefixes, certain suffixes, you can piece them together, and your understanding of terms will be greatly increased. All right, very good. So let's move on. Now let's get into a problem. How many of you have problems? Raise your hand if you too have problems. I know I have problems. I have many, many problems, some of which can be solved easily and those which cannot be solved very easily. If you've known me for any period of time, you know that I have many problems. But problems and science go hand in hand, because science is all about trying to solve problems. And the way a scientist thinks when they're confronted with a problem is to try to solve the problem. Sometimes it's easy, sometimes it's very difficult, and sometimes it's nearly impossible. But the way in which a scientist attempts to solve problems is using a method called the scientific method. The scientific method is a systematic approach to problem solving. What does that mean? It just means that scientists follow certain steps in order to solve a problem. Now, you might think this just relates to a science class or a laboratory. Well, that's not the case, because you can use the scientific method in many endeavors in life. So why don't we talk a little bit about a real life example of where you could use the scientific method. So let's think about this for a moment, shall we? And see the question mark there. That means we're trying to think. Raise your hand if you have a bicycle at home. Anybody have a bike at home? How many of you would rather be riding your bike right now than watching this video? Well, let's look at this young man checking out a bicycle that he would like to ride. And so he's so excited, he gets on the bicycle and, wait a minute. He forgets something. Safety first. So he gets a helmet in order to be safe, and gets ready to ride. He's all excited, ready to ride, until, he realizes that there is a problem. The problem is the front tire is flat. And so in science, the very first thing you need to do is to be able to identify the problem. Don't give up, but identify the problem by asking yourself the question, what do I want to know? And this gentleman's question is, what he wants to know is, well, why is my tire flat? Why is my tire flat? And so he ponders that question and thinks about what the answer could possibly be. What could it be? Could it be that there's a nail in the tire? Could it be that there's a hole in the tire? Or could it be that maybe, just maybe, the tire is not inflated? So what could he do? Well, he could obtain a pump. And using that pump, And following a series of steps by disconnecting the stem valve, by attaching the pump, pumping up the tire, and while pumping up the tire, at the same time, paying attention to, using his senses, what he sees, hears, smells, feels. Well, taste is a sense, but we're not going to use the sense of taste in the laboratory. But using your powers of observation, do the procedures address your hypothesis to answer your problem? Well, let's see what happens here. He's testing the tire again. It seems like it's okay. So this is good news. This is good news. He could make the conclusion that based on the observations of using his various senses, the answer to the problem as to why his tire is flat simply was it wasn't filled up with air. And then knowing that conclusion and solving the problem enables him to have fun on the trail, riding his bike all around the neighborhood, having just a grand old time because, after all, he used the scientific method to solve his problem. Yippee! What a happy camper he is. So here we have used the scientific method to solve a common problem that you might encounter in life in general. So that is the scientific method in a nutshell. Problem, hypothesis, procedure, observation, and finally, conclusion. But as you discovered in yesterday's video, this methodology, these steps, can be repeated over and over again because once you come to a conclusion, the conclusion in this particular case with the bicycle might have been the pumping didn't work. So you'd have to come up with another hypothesis and perform another experiment using procedures and observations to see if it was some other cause for the flat tire. The scientific method is repeatable until you get to a conclusion to your problem. So that's it for today. Tomorrow we'll continue with the next part of our topic. But once you have completed your notes for this particular section on the scientific method, you can use the remainder of your time today to work on the classroom activity in your book on page 21. I hope you enjoyed today's video, and that is it for today. Have a good day, and bye-bye.